Okay, so question number 9 is a little bit deceptive. It looks simple. It just asks, which of the following substances dissolve in water? Explain your answer in terms of polarity. But the podcast, while it technically has all the information that you need, doesn't technically walk you through how to do this. So I want to walk you through all the pieces. So, in order to answer the question of how can I tell if it will dissolve in water? What we talked about is that dissolving comes down to that like dissolves like phrase, which means polar water is going to dissolve other polar things. So if something is polar, it will dissolve in water. That's what our podcast has kind of given us in pieces. But we have to think all the way back to unit 4 or 5. I don't even remember. To remember how to tell if something is polar. So, if you remember, polar molecules have one of two things. Either they have different atoms around the central atom. What I mean is, if I have something like CH4, that's carbon with 4 H's around the outside. So all of those are the same, so this is not polar. But if one of those was like an oxygen instead, or like a chlorine, I don't know why that bothers me, because that wouldn't be oxygen. But let's make that a chlorine just to make me happy. This is totally a molecule that exists, and it's polar just because one of those outer molecules is different. So it either has to have different atoms around the outside, or we have some lone pair or lone pairs on the central atom. And for that, we really would have to draw it out. Or you might be able to tell that something like NH3 has some lone pairs on the central atom because it only has 3 H's to go around the N. The N won't be happy until it has 8 valence electrons, which would mean it has to have 4 things around it. Remember how we were always trying to make things full. So if we only have 3 things bonded around it, must have some lone pairs there. Now, there could be some double bonds. This gets a little tricky, but we're going to teach you some simpler rules later on how to tell if things dissolve. So right now, we're just going to use the skills we've got, and we're not going to try and hide any lone pairs from you. There's not going to be any tricky double bonds. So that's really what it comes down to. That's how we can tell if it's polar or non-polar. Different atoms or lone pairs on that central atom. So, back to the main question. How can I tell if it will dissolve in water? What we've said so far, and this is the part that I might actually want you to write down, just wait until it's all together, is if it's polar, it will dissolve. If it's non-polar, it won't. To be polar, it has to have these 2 things. If it's non-polar, then you have neither of those things. You have to say no to both. But that's only technically a little part of the picture. Those are only for covalent molecules. But don't worry, it's not complicated. If it's ionic instead of being covalent, then it's automatically going to dissolve in water. So we're going to get into a little bit more of that if and when and how you can tell, because some ionic technically don't. But this is the general rule. If it's ionic, it will dissolve. If it's covalent, it has to be polar to dissolve. So that's what we're looking for. So now we can actually get to answering that question after I remind you that the difference between ionic and covalent comes down to what it's made out of. Ionic has a metal at the beginning, which means it has to have something in this middle section down in here. If it has a non-metal at the beginning, or really if it's all non-metals, it either has hydrogen or any of these guys, then that is covalent. So covalent has non-metals only. Ionic starts with a metal, but it will end with a non-metal or 2. So that's how we can tell overall if something's dissolving. So looking at each of these formulas, start by looking if it's ionic. Start by looking for that metal at the beginning. CH4 starts with that C. That is a non-metal, so that's covalent. I can't tell yet. For covalent, I have to look at whether it's polar or non-polar. I actually just drew this one earlier. This is non-polar, has all those H's all around the central atom, no lone pairs. So because this is non-polar, this will not dissolve. I'm just going to kind of put this in parentheses because that's how I'm explaining my answer. KCl. K is in that first column. Alkali metals. So that means that it is instantly ionic. And ionic compounds will always dissolve. I2. That's iodine with itself. That is nonpolar to the instant, like as soon as I even see that. That's a diatomic. There's no difference in the electronegativities. It's all going to be nonpolar. They're nonmetals, and they're definitely the least polar things out there. So because it is nonpolar, what does that mean? It will not dissolve. Now, D starts to look kind of scary, but all I have to do is start by looking at that first element. Mg is in the second column, but those are all still metals, so that is instantly ionic, and ionic are the easiest ones, quickest ones. They will always dissolve. Now, this next one is also kind of big and scary. Looking at it, there's no metals in it either, so I have to decide, this is covalent, if it's polar or nonpolar. But as soon as I'm looking at it, this, if you remember, anything with all of these carbons, C6, is going to be carbons in kind of a long string. That's 6, right? Yep. And then all the rest of this stuff is going to be hanging off the outside. So this is going to be different atoms, H's and O's, and not even equal numbers of them all around the outside. That's going to make it polar, because I have different elements around the outside. Oops, let's bring that back. So I just wanted to get rid of this. Let's see if I can make this work. Because this is a polar covalent molecule, this is going to dissolve. Okay, now last one. Big, scary, but start by looking at the beginning. That is a metal. So this is ionic, and I'm pretty sure you know what this does by this point. So I'll leave that to you, but it really should be pretty straightforward. So that's it for this problem. Whew.